So in statistics, sometimes I like to show confidence intervals, right? And I might have a lower predicted value and it may have an upper predicted value, right? I may have data that has a variance to it, right? I want to show the 95% confidence limits, right? I've got a single prediction, but I've got upper and lower bound. So I might be interested in showing both of those lines and filling in that range, filling in that variance. So what we want to do is we want to talk about filling between the chart for two sets of y. Okay, two sets of y. So what if you have data with a variance, say 95% confidence limits, and you want to represent maybe the center line as well as the upper and lower bounds, and you want to show the y variable prediction and the upper and lower bounds. This chart might be a way to demonstrate that. Okay, so what we want to do, okay, there we go. So let's talk about what is the X data. So the X data are 16 numbers between 0 and 8. Okay, so I'm going to jam in 16 numbers. The two Y data are random numbers. Y1 is multiplied by 4 and adds 3, while Y2 is multiplied by 2 and adding 1. Okay? We're just fabricating data. This is to show two sets of random numbers spread, right? Trying to show that random numbers and their spread, right? And how to plot that, all right? And you can imagine it's called AX fill between, it's AX fill underscore between, creates the shading between Y1 and Y2 across all values of X. The line plot uses X and the simple average of Y1 and Y2. All right, so all we're doing here is we are taking Y1 plus Y2, adding those together, and then dividing by 2. So simple average. All right. What this is going to do, this is going to create a line between the two outcomes of Y1 and Y2. Right? And what we want to make sure we're doing with all of this stuff is you are playing with the parameters and see what happens. So let's make the data. So first thing, we're making, hashtag, making the data. And I want to put this pound, star, get a cell going here. Here we go. So first of all, we're going to start with a random seed, so it's numpy random seed, and we'll seed that random seed at 3. Well, let's seed it at 1, something different. Okay. Then we want to create x. So x is equal to np dot linspace, right? We've seen that before. Well, we start with 0 to 8, and we want 16 numbers between that space. Excellent. All right, let's create y1. Give it some more room here. Okay, let's create y1. So y1 is going to be equal to, right? Remember, I gave you the parameters how we're going to do this. Right, adding 3, so we're going to say y1 is equal to 3 plus 4 times x divided by 8 plus np.random from a uniform distribution, and we want that to be 0.0 to 0.5 the length of x. Okay, so we're going to pull random numbers between 0.0, 0.0 and 0.5. We're going to pull 16 numbers. And then we're going to take those uniform numbers and we're going to add 3 to it. Well, first of all, we're going to take x, right? So I'm going to have 0 to 8 incremented by 0.5, divide by 8, and then multiply that by 4, and then add 3, all right? So y2 is almost the same. So I'm just going to copy and paste this. And here are the differences. So y2 is add 1, multiply 2, and everything else is the same, right? So just creating 2 lines with a spread. Okay. So that's going to give me my data. Now let's make the filled in plot. All right, so we'll go pound, there we go, new cell, and right, you fig ax is equal to plt dot subplots. All right, and let's do our fill first. Ax dot fill between. We want to go fill between x. For all x, we want to fill in between y1, y2. We'll set alpha equal to 0.5, and we'll have our line width equal to 0. All right, we'll see how that turns out. And let's put our plot, ax dot plot x, and what we're going to plot here is the simple average. So we're going to take y1 plus y2, and then we're going to take that divided by 2, and we want a line width equal to 2. All right. My sets are all going to be the same. So I'm going to go back up here because I've typed this several times now, and I'm not going to keep typing it. So I'm just going to copy that. I'm going to use the same set. And we're going to then plt.show. There we go. All right. So I've got my data, I've got my plot, I should be good to go. So let's run this cell and we'll put on variable view so we can see we're going to have x, y1, and y2. So let's run this cell. There we go. We got x, y1, and y2. Now what we're going to do is we're going to run the plot. And let's take a look at what the plot comes up looking like. So we're going to run this plot. And there you go. So here's my y1 plus y2 divided by 2. That is the simple average. Here is the kind of the random number going from 1 to 8, the upper and the lower, and I filled all of that in. Okay, so that's a way to show a confidence interval. If you know what the y1 is, you know what the y2 is, or you know the upper bound and the lower bound, you can put those in for every value of x. All right, excellent.